And in this circuit, we call it resistive circuit because we have a bunch of resistors. But what's important here is that you have a single source. So here we have a single voltage source that's equal to 15 volt. And then we have a bunch of resistors, and the value of all those resistors are given to us. So this resistor R1 has a magnitude of 20 ohms. This is R2, which has a value of 50 ohms. This is R3, which has a value of 15 ohms. R4 is 80 ohms, and finally R5 is 120 ohms. So all the resistor values are given to us, and so is the source value is also given to us. So this kind of circuits are called single source circuits. There is only one single source that supplies the circuit. And the easiest technique to solve for this circuit is to use the R equivalent technique. So in this particular example, we have given you all those values with the voltage source, but we wanted to solve for Ix, which is the current that is flowing through the 120 ohm resistor. So again, the technique to solve for this circuit is to use R equivalent, and then we will be able to solve for the currents through the circuit. So if you will look into the circuit, you can see that this resistor, which is the last resistor R5, going to be in series with the R4. So you can say that the 80 ohm resistor, which is R4, is in series with R5, which is the 120 ohm resistor. Because they are in series, then we can combine those two resistors into one equivalent resistance. So this equivalent resistance, which is the sum of those two resistors, going to be in parallel with this R2 resistor, which is the 50 ohm. So the equivalent of those two series resistors, the 80 ohm plus the 120 ohms, will be in parallel with the 50 ohm resistor. Then those two resistors can be combined into one equivalent resistance. So the equivalent resistance here going to be in series with R1, which is the 120 ohm resistor, and it also be in series with R3, which is the 15 ohm resistor. So now we have three resistors in series where the equivalent resistance can be found easily. It's basically the sum of this resistor plus the equivalent of that resistor plus this resistor. Once we find the overall equivalent resistance, we can solve for the total current flowing through the equivalent resistance using Ohm's law. That's the basic concept on how you are going to solve for the total current, basically by finding R equivalent. Once I total is found, then we know this total current will go through this resistor, which is R1, and then it will branch. Some of that current will go through R2, and the other current will go through this equivalent resistance, which is the same as Ix. So we can solve for Ix using the current divider technique, which I'm going to show you how to do that shortly. So let's go through the steps of finding R equivalent. So the first thing we're going to do is we're going to combine those two resistors into one equivalent resistance. So to do that, basically you're going to add them up. Those two resistors here are going to have this equivalent resistance that we have, and this equivalent resistance is basically the sum of the two resistors. So we're going to call this resistor to be R equivalent 1. Then we're going to say that R equivalent 1 will equal to the 120 ohms plus the 80 ohms, this resistor plus that resistor, which is 200 ohms. So it's crucial to redraw the circuit. So all what we did is we combined those two resistors into one equivalent resistor. Then we're going to draw the remaining of the circuit, and that is the remaining of the circuit. Now what is important here is that Ix, which is the current going through this equivalent resistance, is the same as the current going through the 120 ohm resistor. Because those two resistors are in series, they're going to have the same current. If they have the same current, then Ix going to be the same as the equivalent resistance. So that is important here. So Ix is the same current flowing through the equivalent resistance. So now what we can see is that those two resistors are in parallel. So we can combine those two resistors together. It's easy for us to combine two resistors in parallel into one equivalent resistance. So we're going to do that. And when we do that, then we are going to replace those two resistors with their equivalent resistance. I'm going to call it R equivalent 2, REQ2, R equivalent 2, which is basically the equivalence of 50 ohms in parallel with the 200 ohms, those two resistors in parallel, and that should equal to 40 ohms. Now the question becomes how to evaluate the R equivalent. So most of you will use the product over the sum, which is R2 times R equivalent 1 over RQ plus R equivalent 1. However, this particular technique is a little bit slower. There is a faster way to do it, especially if you are a student and you doing it during the exam. So I'll show you how to do it using your calculator quickly. So what we do, we say that R equivalent 2, which is this resistor, going to be the 200 in parallel with the 50, and we know that this is going to equal to 40. So the way you're going to calculate that is you're going to say that the 200 reciprocal. Every calculator almost have this button where you have 1 over x or x to the minus 1. So you say 200 reciprocal, which means that the inverse of that, and then you're going to do plus 50 reciprocal. So basically here what you're doing is you are adding the reciprocals, and by adding the reciprocals you get the result. Now then R equivalent is basically the reciprocal of the sum of the reciprocals. This is the best method you can have or do to calculate R equivalent using the calculator. It's the fastest way of doing it. It's much faster than doing the product over the sum. But anyway, when you do that, you will get the answer going to be 40 ohms. So we were able to calculate R equivalent to be 80 ohms. Now this technique is a little bit faster. I recommend the students to do it, and it doesn't have to be for two resistors. It can be for 3 or 4 or more resistors in parallel. Basically you add the reciprocals, you get the result, then do the reciprocal again, and that's basically going to be R equivalent. So this is R equivalent, which combines those two resistors together. Now we're going to draw the rest of the circuit, which is this part of the circuit. So when we draw the rest of the circuit, basically we're going to have the 20 ohms and the 15 volts and then the 15 ohm again. So that's what we have. You draw the rest of the circuit. But what's important here is that the total current that's supplied by the voltage source, which flow through the 20 ohm resistor in this circuit and this circuit, going to be the same. Now we can find the total current easily if we can find the R equivalent of those three resistors in series. So the equivalent resistance basically going to be the sum of those three resistors, and we can say that R equivalent will equal to the 20 ohms, that's the 20 ohms here, plus the 40 ohms, that's the 40 ohms, plus the 15 ohms, and that's the 15 ohms, which will equal to 75 ohms. So now we found R equivalent, then we can find the total current easily. The total current is basically nothing but the Vs over R equivalent. Vs is the 15 volts over the total equivalent resistance, which is the 75 ohms. So we have 15 over 75, and that's going to basically give us 0.2 amps. Now we know that the current going to be 0.2 amps. So we solved for the total current. So this is the total current we solved for, which corresponds to this total current. But that's not what I'm after. I'm after Ix. So I need to solve for this current, Ix. And to solve for this current Ix, I can use the concept of current divider. Whenever I have two resistors in parallel, if I have two resistors in parallel, and I know the total current going through those two parallel resistors, which is I total, so the total current will go through those two resistors, then the current through this resistor, the 200 ohm resistor, by using the current divider concept, is basically the opposite resistor, which is the 50 ohms, over the sum, which is the 50 ohms plus the 200 ohms, times the total current, which is IT. So then we can say that Ix will equal to R2 over R2 plus R equivalent times the total current. This is the current divider. It's the opposite resistor over the sum of the two resistors times the total current. So the opposite resistor is 50 ohms over 50 plus 200 times the total current, which is 0.2, and this will equal to 40 milliamps. So in summary, if you basically wanted to solve for a single source circuit and you have all the values for the resistors and you have the value of that source, whether it is voltage source or current source, the best way to do it is to find R equivalent, and then you can use voltage and current dividers to solve for any voltage or current in the circuit. That's the easiest way out, because some of you who learn different techniques, or they're gonna learn different techniques, you can solve for the same circuit using nodal analysis, or you can use mesh analysis. You're gonna have I1 here and I2 here, and you can do mesh analysis. Those techniques are gonna be more complicated. It is easier to find R equivalent, just like we did here. And once you find R equivalent, then you can work the circuit using current and voltage divider. In this particular example, we used current divider to solve for Ix. So the easiest technique to do for single source circuit is basically R equivalent, and that's something that we need